Great, so here we're going to be looking at number 7 from 4.5. And we're going to be using the variation of parameters method for this one, since the right-hand side, I have no idea how to guess a particular solution. So step 1, we're going to look for a homogeneous solution. So we're going to solve the equation where there's a 0 on the right-hand side using our characteristic equation. And solving this just by factoring, we need to think of two numbers that multiply into 2 and add into -3, so minus 1 and r minus 2. So this gives you the roots of +1 or +2 for r. So this tells me my general solution has, or for my homogeneous solution rather, c1 e to the t plus c2 e to the 2t. Right, so this is going to be called y1, this will be called y2. It'll also be helpful for me to look at the derivatives of these. So I would also note that y1 prime, let me look at it below. So note that y1 prime is e to the t, and y2 prime is 2 e to the 2t. All right, great. So looking at my homogeneous solution, it lends itself in the variation of parameters method to the solution y particular equals v1, which is a function of t now, e to the t, plus v2, which is also a function of t, e to the 2t. So that's the particular solution. Now, in order to solve it, instead of going through the labor of taking the derivatives a couple of times, plugging it back in, remembering other parameters, the whole solution boils down to solving two smaller conditions. So the conditions are first that y1 times v1 prime. So notice I like to write it this way: v1 prime, v2 prime. Notice there's going to be those in all four places. So I'm going to first establish that y1, right, plus y2 here equal to 0. So y1 in this case, though, we found that was e to the t plus e to the 2t equal to 0. And then y1 prime e to the t plus 2 e to the 2t is equal to the forcing function. So our forcing function here is a little bit strange. 1 over 1 plus e to the negative t. So there's our forcing function. So this is our system of equations that we need to solve. So we can decide to do it either algebraically or using Cramer's rule, which involves the Wronskian and all those nice, bells and whistles. It's really up to you what you prefer. But because this one has the exact same terms for here and here, it's going to be a lot easier to just subtract one of these equations from the other. So let's just subtract the top one from the bottom. If we do that, notice what we're given. So here's us solving this. So to solve this for v1 prime and v2 prime, if I subtract the top from the bottom, I have 0 plus e to the 2t v2 prime is equal to 1 over 1 plus e to the negative t. Great, so this actually tells me, this is pretty quick, that v2 prime is equal to e to the negative 2t divided by 1 plus e to the negative t. All right, great. And then for v1, that's also now not too far gone, since we can just plug this back into one of our equations. So let's plug it into the top. So e to the t v1 prime plus e to the 2t times, well, actually, let's be smart about this. E to the 2t times v2 prime, we already know what that is. That's 1 over 1 plus e to the negative t. And that's going to be equal to 0, right? And so we can subtract this and then divide, so we end up with v1 prime is equal to negative e to the negative t divided by 1 plus e to the negative t. Great, so here's one of our derivatives. Here's the other one. So we need to integrate both of these. So that would be step 3 in our method. So for step 3, let's write that down here. We're going to take some integrals. So v1 will be the integral of negative e to the negative t over 1 plus e to the negative t dt. You notice if I used u substitution, this would actually just where u, let me do it in yellow. If we let u, not u, but the letter u, let u be e to the negative t, then this equation becomes du over, actually this might even be a better substitution. It doesn't make a difference, but if we let it be 1 plus e to the negative t, then the whole thing just turns into u. So this just gives you the natural log of that. So the natural log of 1 plus e to the negative t. And that's always positive, so the absolute values are kind of redundant. So there's v1. Now we need to grab down v2. Just grab that equation. Great, now to integrate this one, we're going to need to mess with it a little bit. So there's something kind of like partial fraction decomp. Let's just sort of do a side story here. We might think, well, how can I make this soluble since I have that e to the negative 2t up top? Here's something that you could think about. Here's the clever trick. What if I wanted to write this fraction as some number plus some other number over 1 plus e to the negative t? And these could be functions of t. They don't just have to be constants. If I wanted to write it that way, well, there's a couple possibilities. Maybe this is just 0, right, and b is just e to the negative 2t, but there might be other ways. So what I can do is, in the method of sort of partial fraction decomp, recognize that this could be a, if I put it over the same fraction, plus a e to the negative t, plus b, so all this is over 1 plus e to the negative t, and I need that to equal this. So we saw, yeah, one option, is if I want b to be e to the negative 2t, a could just be 0. But there's another option hidden in there. What if I want that middle term to account for the negative 2t? If that's to happen, then I would need a e to the negative t to equal 2t, and then I would want a plus b to go away. So partial fraction decomp here, with a little twist. And so to solve this one, a would be e to the negative t, and b would be negative e to the negative t. Great, so that tells me that's a way of writing the innards there. So what does that mean? Well, I can rewrite this integral, then, the fraction in there, as e to the negative t plus negative e to the negative t. So that's your b over 1 plus e to the negative t. So this is, I'm sort of saying, here's my a and my b over that stuff. Okay, so this right here, the reason we did that is much easier to integrate since the first integral is just negative e to the negative t, and then we add to that, well, that's exactly what we had done before. So plus the natural log of 1 plus e to the negative t. So there is my v2. So we have v1 but in blue. So this is my v1, this is my v2. So actually, we're pretty much done. We just now, in our last steps, just plug this in. So y particular then was y1. At this point, I forgot what was y1. E to the t. Is that correct? Yeah. So y1, so e to the t times v1, right there. E to the t times the natural log of this stuff. Plus y2, which was being e to the 2t times this stuff. Negative e to the negative t plus natural log of 1 plus. There's my particular solution. Hey, great. If I want the whole general solution, then you would say, well, my general solution is my homogeneous plus my particular. So the homogeneous was this stuff. Much nicer than the other one. But then, yeah, the whole kit and caboodle comes and stick it right there. All right, there you go. Hope this helps.